Hi guys. So today we are going to start a new unit, which is going to be a little bit different than what we've done so far. For some of you, this may be a little bit harder. For some of you, this may actually be easier. It really just kind of depends. But what we're going to do is we're going to look at some different identities using our trig functions and trig expressions. And what we're going to do is we're going to take certain expressions and use those identities to be able to simplify them or make them look just a little bit different. So there's a few identities we're going to look at that we already know. And the first ones are the reciprocal identities. So for example, 1 over sine, we know that's the same thing as cosecant. Okay, those are the reciprocals of each other. That also means that 1 over cosecant is the same thing as sine. 1 over cosine is the same thing as secant. So 1 over secant is the same thing as cosine. 1 over tan is cotan, and 1 over cotan is tan. So these are ones we actually have looked at before. Two others that we've looked at before are the quotient identities. So sine divided by cosine, we know that's the same thing as tangent. And cosine divided by sine, that's the same thing as cotangent. So what we're going to start is just use those identities before we look at some of the new ones. And what we're going to do is we're going to take an expression and we're going to try and simplify it. Now, the reason some of you may not like this is there's not really one particular way that you have to do these. There's a lot of different ways that you can do these. So that's what makes them a little bit tricky for some people. Now, we'll look at some strategies, but the way that I do it may not be the same way that you'll do it. So it's really just kind of up to you. All right, so let's look at this first one. Sine x times cosecant x. Now, again, we'll talk about a lot of different strategies, but one thing that is usually kind of helpful is to rewrite things in terms of sines and cosines. So what I mean by that is I'm going to rewrite cosecant using its reciprocal. Cosecant is the same thing as 1 over sine. Now, I'll also tell you guys, you will be given these identities. You'll be given kind of a formula sheet with all of them. But the more familiar you are with them, the easier it's going to make these problems. And the more of them you do, the more of them you're going to know as well. All right, so sine x, remember that's the same thing as sine over 1. And well, what happens here, you'll probably notice, if you have sine over 1 times 1 over sine, if they're being multiplied together, those signs are going to cancel out, and this whole thing is just 1. All right, let's look at b. Again, more than one way to do this, but what I would do, tangent is the same thing as sine over cosine. Cosine, we can just rewrite as cosine over 1. Well, what's going to happen now, since we're multiplying, okay, we can cancel out those cosines because they're being multiplied together, and I'm left with just sine. All right, let's look at c. There is, more than one way to do this. So what I'm going to do is I know tangent and cotangent are reciprocals. So I'm going to rewrite this. I'm going to rewrite cotangent as 1 over tangent. That tangent is tangent over 1. Well, again, since they're multiplied, those tangents can cancel out, and I'm left with 1. But again, that's not the only way to do it. Let's say instead you wrote everything in terms of sine and cosine. Well, I could have done tangent is sine over cosine. All right, so I can rewrite tangent as sine over cosine, and I could rewrite cotangent as cosine over sine. So it's just a different way of working it out. I'm still going to get the same answer, though, because cosines cancel, sines cancel, and all I'm left with is 1. All right, if you feel comfortable, pause the video, try this next one on your own. All right, so what I'm going to do is I'm going to rewrite this as sine over 1. I'm going to rewrite secant as 1 over cosine. And then I'm going to rewrite cotangent as cosine over sine. And sometimes you really just have to kind of try different things to see what's going to work out for you. So, for example, here, the cosines cancel, the sines cancel, and I'm left with 1. Now, I know a lot of these so far have equaled 1. That's not always what's going to happen. A lot of times you'll see a different function, but early on, this is what a lot of them are. All right, so let's try another one. If I can get this to switch. There we go. Okay, so a little bit of a different notation we haven't really seen. When you see a cosine and then the squared is right there, what that means is cosine x, that whole thing squared. So what that really means is cosine x times cosine x. You just see the squared written there, because if I wrote it this way, it's really hard to tell if the x is being squared or if the whole thing is being squared. So if the whole thing is being squared, that's why we write the 2 there. Okay, I'll write that as cosine over 1 and cosine over 1. Cosecant, that's the same thing as 1 over sine. Secant is the same thing as 1 over cosine. So your cosines cancel out. You're left with cosine over sine. And cosine over sine is the same thing as cotangent. And that's as simplified as you can get. Again, there's a different way you could have gone there, but that might be the simplest. So again, a good strategy a lot of times is to rewrite things in terms of sine and cosine. All right, now let's look at this one. Okay, so what I'm going to do, this is sine x divided by tangent. Now, when we start dividing, it gets a little bit tricky. So I'm going to go ahead and rewrite this as sine x over 1 times 1 over tan x. Okay, because that's the same thing, it's just written a little bit differently. That might make it a little bit easier to see. All right, well, 1 over tangent is the same thing as cotangent. So this is the same thing as cotangent. Cotangent is the same thing as cosine over sine. So your sines cancel out, and you're left with cosine. Again, that's not the only way to get to your answer. A different way you could have done this, I could have rewritten this as sine divided by tan. So this is sine divided by sine over cosine. And when you divide, you keep, change, flip. So I would keep, change, and flip. And I still get to the same answer, just a different way of doing it. Whichever way seems the easiest to you is the best way to do it. So those are just some examples using some of the properties that we've already seen. So again, there's more than one way to do this. You can try, depending on what you have, factoring, foiling, rewriting things in terms of sine and cosine. If we have things that we can add with fractions, we might need to get a common denominator. These are some things that you'll start to see in some of the more complex problems. What we're also going to introduce are some additional new identities. Now, we're not going to get into kind of the hows and the whys where all these things come from. We're welcome to do that in class if you guys are curious. But the most important one of these is this sine squared plus cosine squared equals 1. Now, they're called Pythagorean identities just because of how they're derived. It comes from using Pythagorean theorem. But this one right here is actually where these other two come from. These other two come from taking that original and dividing by sine or dividing by cosine. But again, you'll be given these 3 identities. But what you need to be familiar with is how we can rewrite these identities. And what I mean by that, for example, is I can take this identity right here, and I can rewrite it if I subtract cosine squared from both sides. What I get is a different looking identity that means the same thing. So this is another way of writing this out. What I also could have done, instead of subtracting cosine squared, if I subtracted sine squared, then I would get another form of this identity that I could use for these proofs. And I can do the same thing on these ones. I could rewrite them. So for example, I could take this original and I could subtract tangent squared to get another form of that identity. Or I could subtract 1 to get another form of that identity. Again, these are different ways to rewrite it. Now, these two, we're going to focus more on those next class. So for today, we're really going to focus on just the variations of this one. But we'll kind of rewrite some of those out next class. All right, so again, there's different ways to work these out. Now, in this case, what I'm going to want to do, I know if you go back and look at those identities, if I rewrite them, okay, sine squared plus cosine squared is equal to 1. If I rewrite this, if I subtract cosine squared from both sides, I get that sine squared is equal to 1 minus cosine squared. Now, that is not the same thing as 1 minus cosine. I can't replace 1 minus cosine. What I can do, though, you may recognize this is a difference of squares. If I multiply this all out, those middle terms cancel out, and I just am left with 1 minus cosine squared. 1 minus cosine squared is the same thing as sine squared. And I wrote a theta instead of an x. And that is your simplified answer. All right, again, more than one way to do these, but what I'm going to do over here, okay, cosecant times sine. Again, the more familiar you are with these identities are, the easier it's going to be. You may remember cosecant is sine's reciprocal, which means cosecant is 1 over sine. Well, if you do 1 over sine times sine, you get 1. The cosine squared hasn't changed. 1 minus cosine squared is the same thing as sine squared. So that's why, again, it's really important to be familiar with these because it makes them a lot easier because you kind of know some ideas of some things you can do. All right, let's look at this next one. Cosine squared times tangent divided by sine. Again, more than one way to get there. What I'm going to do is I'm going to go ahead and start by rewriting tangent. So I'll rewrite cosine squared as cosine times cosine. I'm going to rewrite tangent as sine over cosine. And then this whole thing is divided by sine. So I'm going to start by looking at just the top of this fraction. Okay, well, those cosines are going to cancel out because it's all multiplied together. That's going to leave me with cosine times sine at the top of this fraction and sine at the bottom of this fraction. Now your sines can cancel out and you're left with cosine. All right, and again, I say there's more than one way to do it because, again, looking at D, there's a couple different things you can do. You can distribute and try and simplify from there. You can try and simplify the stuff that's on the inside, whichever way you think is going to be easier. So I'm going to go ahead and do this one by distributing. So I'm going to do cosine times secant. And then I'm going to do cosine times cosine, which would be cosine squared. And if you notice, there's not a plus in between those. That means that's all one term. Okay, so cosine times secant, that's 1. Then I have cosine squared times cosecant squared. So that's cosine times cosine times 1 over sine times 1 over sine. So nothing cancels out, but cosine over sine is cotangent. And then another cosine over sine is also a cotangent. So you get cotangent squared. And that's one of those Pythagorean identities that we have where 1 plus cotangent squared is cosecant squared. Now again, that's not the only way that you could have done this. So another option could have involved using some fractions. Now this might be a little bit harder, but we'll do a little bit more with some fractions later on. What I'm going to do is try and simplify all this stuff in the middle first. So I'm going to rewrite secant as 1 over cosine. Okay, sorry about that. And then, again, I'm going to rewrite cosecant squared as sine squared. Now, this may seem like a harder way to do this for a lot of you guys, but I want to introduce this idea of adding fractions because that is something we're going to need to see. Okay, so since these two terms on the right are multiplied, I can just write this as cosine over sine squared. And then what we're going to do is we're actually going to add these two fractions together. Well, in order to add fractions together, you have to have a common denominator. So this is going to take you back to Algebra 2, whenever you had things like this, and you had to add them together. You had to get that common denominator and combine them together. Well, that's what we're going to do here. That common denominator, the left fraction has a cosine, so it needs a sine squared. The right fraction has the sine squared, so it needs the cosine. So now you have the same denominator on both fractions. and you're able to add them together. Sine squared plus cosine squared is one of those Pythagorean identities. So sine squared plus cosine squared is 1. And then if you remember, this whole thing, all we were doing right there is messing with the inside. That whole thing is multiplied by cosine, which means the cosines are going to cancel out. You're left with 1 over sine squared, and the reciprocal of sine is cosecant. So you end up with the same answer, you just get there a longer and probably more difficult way, but it still works. All right. So we're going to try 2 more. Again, you can try these on your own, and that's actually a really good idea. The only way to really get good at these is just to try a bunch of them different ways. You may try a way and realize it's not working and have to go back and do it a different way, and that's okay. Sometimes the struggle of these is what really helps you learn how to do them and really understand the way they work. The more of them you do, the easier they're going to get. All right, so let's go ahead and look at this one. So I'm going to put everything in terms of sine and cosine. That's kind of a good strategy when you're not really sure what to do. Cotangent is cosine over sine, and that's cosine over 1. Well, those 2 on the right are multiplied together. So since they're multiplied together, I'm going to rewrite it as cosine squared. Well, now I have 2 fractions that I can add together if I get a common denominator. The right fraction has sine in the denominator, so the left fraction needs to get multiplied by sine, top and bottom. Sine times sine is sine squared. Now you have the same denominator. So when you add fractions, the denominator stays, and you can just add the top. Sine squared plus cosine squared is one of those identities. It's just 1. And 1 over sine is cosecant. All right, so last one. Again, this gets a little tricky. There's a couple different ways you could work this one out. So what I'm going to do here is I'm just going to try to start by simplifying the numerator, okay? And I'm going to do this very similar to the way I just did the last one. I'm going to rewrite cotangent in terms of cosine and sine. And I have 2 fractions. Now, remember, this is just the top. So in order to combine these together, I'm going to need a common denominator, which means that I'm going to need to multiply the right fraction by sine, top and bottom. And sometimes, you guys, you're going to notice I'm going to forget to write those x's. That's okay if you do the same. It just gets a little bit easier when you are writing it over and over again. All right, so then I'm going to have cosine x minus sine squared cosine x over sine x. And again, this is just the top of the fraction. We're just simplifying all this first. At this point, you may not know where to go, okay? But one thing you can do is you may realize both terms have a cosine. Well, if both terms have a cosine, I can factor it out. So I'm going to factor out the cosine. And again, that's why it's really a little bit of trial and error to figure out what you can do. What I'll tell you, you cannot do, and a really common mistake, is to try to cancel out the signs here. That is something we cannot do because there has to be a sign in this expression in order to actually be able to do that, and we don't have that. Think like quadratic formula. Okay, those 2's can't cancel. There has to be a 2 in all of those places in order for it to work out. All right, so now, using what we know about those trig functions, 1 minus sine squared is the same thing as cosine squared. And then all we did there again was we simplified the top. This whole thing was divided by cosine squared, which means it's multiplied by 1 over cosine squared. Cosine squareds cancel out. You're left with cosine over sine, which is cotangent. So all of that work to get down to just little old cotangent. All right, now again, there's different ways you can do this. So I'm going to show you guys one more way to work this one out, because that was kind of a lot. What I'm going to do actually is simplify these into two separate fractions. Okay, so both of these have a denominator of cosine squared. So I'm going to rewrite this as cotan x over cosine squared x minus sine x cosine x over cosine squared x. All right, and the reason I'm going to do that now is because these are multiplied. I can take one of those cosines and multiply it out. So that means I can rewrite this as cotangent x over cosine squared x minus sine x over cosine x. I can rewrite cotangent as cosine x over sine x times 1 over cosine squared, and I can get one of those cosines to cancel out. So this is what I'm left with on the left fraction. This is what I'm left with on the right fraction. Now I can try and get a common denominator, and I'm a step ahead of myself there. I can multiply the right fraction by sine. Now I have the same denominator. And then I have a Pythagorean identity. So 1 minus sine squared is cosine squared. Your cosine will cancel out with one of your cosines. You're left with cosine over sine, which gives you cotangent. Same answer, a different way of getting there. So again, I know these are going to be a little bit tough. You really just got to try something and try to work your way through it. If it doesn't work out, try something different. We'll practice them a lot in class. We're going to spend a lot of time on these to hopefully make them a little bit easier.